Did you know that a single solar flare can release the energy of billions of atomic bombs? That's right, these powerful events on the sun are a testament to the immense forces at play in our solar system. These flares are not just fascinating spectacles, they can have a real impact on our planet. Understanding what causes these flares and how they affect us is crucial for protecting our technology and way of life. So let's delve into the heart of the sun and uncover the secrets behind these awe-inspiring events. Solar flares are caused by the sudden release of magnetic energy stored in the sun's atmosphere. When these magnetic fields become twisted and tangled, they can snap and reconnect, releasing vast amounts of energy. This energy travels through space and can disrupt satellites' communication systems and even power grids on Earth. Scientists use advanced technology to monitor and predict solar flares, helping us prepare for their potential impacts. By studying these phenomena, we gain a deeper understanding of our sun and its influence on the solar system. The sun, our life-giving star, continues to amaze us with its power and complexity. As we continue to explore and learn, we uncover more about the incredible forces that shape our universe. So next time you look up at the sun, remember the incredible energy it holds and the mysteries it still holds for us to discover. Solar flares are intense bursts of energy from the sun's surface. These flares are among the most powerful events in our solar system, capable of releasing as much energy as billions of atomic bombs detonating simultaneously. They occur when magnetic energy that has built up in the sun's atmosphere is suddenly released. This magnetic energy is stored in the sun's outer layer, known as the corona, where the magnetic field is highly dynamic and constantly changing. Think of it like a rubber band being stretched and then suddenly snapping. The tension builds up over time, and when it finally breaks, it releases a tremendous amount of energy in an instant. The sun's magnetic field lines get twisted and tangled. These magnetic lines are like invisible threads that weave through the sun's atmosphere, and their interactions can become incredibly complex. This creates a huge amount of stored energy. Over time, as the magnetic field lines twist and turn, they store more and more energy, much like winding up a spring. When these lines finally break and reconnect, the stored energy is released in a powerful explosion. This process is known as magnetic reconnection, and it is the key mechanism behind solar flares. This explosion is what we see as a solar flare. These flares can have significant effects on space weather, potentially disrupting satellite communications and even power grids on Earth. Understanding solar flares is crucial for predicting and mitigating their impact on our technology-dependent world. Sunspots, those dark patches on the sun's surface, are closely linked to solar flares. These fascinating features are not just random blemishes, but are crucial to understanding solar activity. These spots appear darker because they are cooler than the surrounding areas. While the sun's surface temperature is around 5,500 degrees Celsius, sunspots are relatively cooler at about 3,500 degrees Celsius. Sunspots are regions of intense magnetic activity. This magnetic activity is so strong that it inhibits the convective transport of heat from the sun's interior to its surface, causing the cooler, darker appearance. They are like giant magnets on the sun's surface. These magnetic fields are thousands of times stronger than Earth's magnetic field. The complex magnetic fields around sunspots can become twisted and tangled, eventually leading to the release of energy in the form of solar flares. These solar flares are powerful bursts of radiation that can impact space weather and even affect communications on Earth. So, the more sunspots we observe, the higher the chances of solar flares erupting. During periods of high solar activity, known as solar maximum, the sun can be dotted with dozens of sunspots, each a potential source of solar storms. Understanding sunspots and their behavior is essential for predicting solar flares and protecting our technology-dependent society from their effects.